Hey guys, Mr. Betts here. If you haven't had a chance to complete this page, pause the video right now, complete the page, and then I will go over it with you. If you have finished it, let's talk about it. So the idea here is we want to decide which calculation given is the correct one to answer the question in the problem. And then this part B here, I want you to do this on your own. Practice what we learned in class with using the calculator for finding derivatives and values of functions. And so actually confirm the values that are given here. So the 73.900 and the 0.030, use your calculator to confirm that you can get those answers, because that's something that you'll need to be able to do. And then we want to provide units for both calculations, even the one that's not actually being used to answer the question. So in number one, we have water flowing into a tank. So the volume in the water is given by the function v of t. Volume's measured in liters, t is measured in seconds. At what rate is the amount of water in the tank increasing after 15 seconds? So a key word here is rate. Another one says increasing. So if we're looking for a rate, then what we're looking for is a derivative. So we're looking for the derivative here. Units on that derivative, let's start with that since that's what we're looking for. Units are going to be the units for V, which is liters, divided by units for T, which is seconds. So it's going to be liters per second. The units on V are just given to us in the problem. Things that are given by the function V are measured in liters, so this is going to be liters. Number two, we have oil being shipped out of a tank at a rate of S, and S is given in gallons per hour. So I want to point out that S itself is a rate, and T is measured in hours. At what rate is oil being siphoned out of a tank? I said shipped. I meant siphoned. Siphoned out of the tank after 2.4 hours have elapsed. So in this particular problem, this is a little bit tricky because it's asking for a rate, which makes us think that we should be looking for a derivative, but we need to keep in mind that S is itself a rate. So what we're looking for here is how fast oil is being siphoned. That's exactly what the function S gives us. So what we want here is the value of S at 2.4. The units on that are the units that are given for S, which are gallons per hour. If we did take the derivative of S at 2.4, that's telling us how fast that rate is changing. So what this number right here tells us is that on average, at this instant, 3.451 gallons are entering the tank every hour. So I know it's weird to say at an instant it's happening per hour, but if it were to stay at that rate, 3.451 gallons would enter the tank in an hour. What this is telling us is that rate is actually decreasing. So even though we have 3.451 gallons going into the tank per hour, that rate is going down. So oil is being siphoned out at a slower rate as time goes on, at least at this point. More importantly, the units that we're going to use here are going to be the units for S divided by the units for time, which will be gallons per hour per hour. So since the rate itself is changing, the rate is given in gallons per hour, and that's changing at a rate per hour. So it's gallons per hour per hour. That was a pretty quick one. So let's continue with the next page here. In activity 2, essentially what we want to do is something that you're going to be asked to do on the AP test, which is to take the value you get for a derivative and explain what it means. So we've already done that, but we're just going to practice writing that out entirely now. So this page is basically just an introduction and showing here's a few different ways that we could do that for this particular problem. So in the prompt given here, we have V giving the volume of water measured in gallons in some tank given at some time, where T is measured in minutes. So we want to explain the meaning of V prime of 5 equals -6. When we're giving an explanation, we want to make sure that we explain what the 5 means, what the 6 means, what the sign of the 6 means, so whether that's positive or negative and what that means, and we want to include units for all of that. So some acceptable explanations would be after 5 minutes, so that's telling what the 5 means with units. The volume of the tank is decreasing, that's telling us what the negative is. Volume is decreasing at a rate of 6 gallons per minute. So it's telling us what the 6 is, and it's telling us the units on the 6. So we're being told here that the derivative is giving us a rate. We know what the 5 means, we know what the 6 means, we know what the negative on the 6 means, and we have units for all of that. All of these explanations include that. I do want to point out that this one right here does not use the word at a rate of, which is okay, but by using the word at a rate of, the phrase at a rate of, it explains what you mean. So any one of these 4 explanations would be okay because they include that it's a rate that the volume is changing. It tells what the 5 is with units, it tells what the 6 is with units, and what the negative means. So we have decreasing here, we have going down here, decreasing here, we have decreasing here. So those are all explaining the negative. Things that would not be okay. So the first one, it says after 5 minutes, the amount of water in the tank is changing at a rate of 6 gallons per minute. We don't know if it's changing in a positive direction or a negative direction. So this would be too vague because we don't know if the water in the tank is increasing or decreasing. The second one, it says after 5 minutes, the instantaneous rate of change of water in the tank is negative 6 gallons per minute. We don't want to include the negative or the positive in our answer here when we're explaining. Explain what that negative means. So instead of putting the negative there, we want to say that it's decreasing. So some examples on your, we have a couple more that are wrong. So after 5 minutes, the rate of change in the water is decreasing at 6 gallons per minute. So we need to be really careful here that we say the rate of change is decreasing. So the rate of change is already saying how fast something's changing. And then if we say that's decreasing, what we're actually talking about is the second derivative. So we want to be careful with our language that we don't accidentally take another derivative when we're not supposed to. The other thing that it said, the other incorrect explanation would be using some sort of time interval. We need to make sure that we make it clear that that our value is at an instant and it's not over some time interval if we're using a derivative. So we don't want to say over some time period it's going to decrease by 6 gallons because that rate could be changing as time goes on, and so this would not be correct. So you can read through, you guys can read on your own, but you can read through this here. But we want to make sure that that we're not using words that are incorrect. So increasing at a rate of or decreasing at a rate of, and then we use the absolute value of the derivative, so we're taking out the sign. So this is something we've already talked about here. So prompt 1, let's go ahead and do that together real quick. So prompt 1, we have a differentiable function c. C is measured in dollars. So we've already seen this example. Now we're actually going to tell what an answer means in the context of this problem. So the cost of the whole is changing. That's what the derivative is telling us. So we want to answer with what the 20 means, what the 55 means. All right, so let's start with the 20. The 20 is the x value that we're plugging in, and that's the depth of the hole. So we can say when the hole is 20 feet deep. Okay, then we want to talk about what that 55 means. The 55 is an instantaneous rate of change. So the cost of digging the hole that's a positive 55, so that's increasing at a rate of 55. And then we want to make sure we include units. So I'm just going to put the dollar sign here, $55 per foot. Okay, to be clear, this does not mean that the next foot is going to cost $55. It also does not mean that the next foot is going to cost $55 more than the previous foot. If this derivative were a constant, if it was always 55, then that would be true. But we want to make sure we don't interpret this as the rate of change over an extended time. It's the rate of change at a particular time. So take a moment, pause the video, try to answer prompt 2 and prompt 3 in the same way, explain what those two derivatives mean, and then we'll go over that together. So welcome back. Hopefully you have given these two an attempt here. So for the prompt number 2, we want to explain the meaning of h prime of 20 equals 510. So first, let's talk about what that 20 means. And before I get started here, I want to mention that we don't necessarily have to do things in the same order, but we want to make sure that what we write makes sense and means the same thing as what I'm about to write. So I always like to start with what the input value means. So in this case, this is going to be 20 seconds after launch. So I said what the 20 means and what the units are on that. The rocket, so we could say the rocket's height is increasing, but that's kind of awkward wording. So I'm going to say the rocket is rising, or we could say is going up at a rate of 510 meters per second. Okay, again, this does not mean that the rocket is going to travel 510 meters in that 20th second, okay, over that time interval. It means at that moment, if the rate stayed the same, then it would increase 510 meters in that time period, but it is an instantaneous rate of change. The last one, we have bacteria in a petri dish. So again, I'll start with what that 12 means. So after 12 minutes, so it says T minutes of observation. So we could say after 12 minutes of observation, the derivative P is going to be measured in bacteria per minute. That is a positive value. So the number of bacteria is increasing because our derivative is positive at a rate of 720 bacteria per minute. It's pretty fast reproduction for bacteria. We said what the 12 means with units, we said what the 720 means with units, and we said what the positive value of the 720 means as far as increasing or decreasing.